Hello everyone, hello. Let's. Hi, good evening. Join now. Do it fast. I am live today. So in this live session, we are going to discuss about the mechanics. Last session we have discussed about the kinematic equation. If you have not seen the videos, please go in the live section in my YouTube channel and see that video. See that video. Last class we had discussed about the kinematic equation. First equation is B equal to ut plus u plus half at, and second equation we have discussed about the ut plus half at square, and third equation we have discussed about the v square equal to u square plus 2as. But today's session, today in this live session we are going to discuss and learn about the mechanics. So in the mechanics, we will discuss about the friction, pressure, density, torque, Hooke's law, Newton's second laws, kinetic energy, gravitational potential energy, momentum, work, power, centripetal force, impulse, weight, and spring, potential energy, centripetal acceleration. So these things we will discuss today in this videos, in this live session. So please join everybody. Only two members, two person. Please join fast. I am waiting for you, student. I am waiting for you. Please join it fast. Only one. Okay, let's start first. Friction formula is F equal to mu n. What is it? Friction fights motion. Friction fight motion means it opposes the motion. It depends on how slippery the surface or coefficient. Mu is nothing but it is a coefficient, and how hard they are pressed together. So normal force N capital N stand for the normal force. So rough surface equal to more friction. Here in this formula, friction formula, F equal to mu N, where F stand for the friction force and mu stand for the coefficient, and N stand for the normal force. N stand for the normal force. Next we will discuss here about the pressure. Pressure formula. What is pressure formula? We know, you know na, childrens. Everybody say in the comment box, write it in the chat box. Write it in the chat box. Everybody. What is the pressure formula? Yes, pressure equal to, what is the pressure? P equal to force upon area. Pressure equal to force upon area, where P represent pressure, F represent force, and A represent area. So what is it? Why does a pin hurt but a finger does not? The pin allows the same force to be concentrated on a tiny area, creating huge pressure. So here in this, what is it? It is written, while we are inserting pin in a notice board, so we are able to penetrate the notice board. We are able to penetrate the notice board with the help of pin, but if we are inserting our finger in the notice board, so we are not able to insert in it. Yes or not? Why? because the surface area of finger is maximum as compared to the pin. So in the pressure formula, P equal to F upon A, where P stand for pressure and F stand for force and A stand for area. Now next density. Density, what is the density? What is the density? Do write in the chat box. Write in the chat box, everybody. Yes. Rho equal to m upon b. Rho equal to m upon b, where rho stand for density and m stand for mass and b stand for volume. B stand for volume. What is the SI unit of density? Kilogram per meter cube. What is the SI unit of density? Kilogram per meter cube. But what is the SI unit of pressure? The SI unit of pressure is, what is the SI unit of pressure, children? SI unit pressure is Newton per meter square. Newton per meter square. And density SI unit is kilogram per meter cube or gram per centimeter cube. Now next which we have torque. Torque we are representing with Greek letter tau. So tau equal to R into F sin theta. Torque formula, tau equal to R into F sin theta. What is it? So want to loosen a tight bolt, use a longer wrench R, and torque is the rotational twist pushing perpendicular 90 degrees gives maximum twist. So sin 90 equal to 1. So here torque equal to tau represent as a torque in Newton meter, and R stand for the lever arm in meter, and F stand for force, and theta stand for the angle between the torque and then lever, between the lever and then which force we are applying over the lever. So the final formula for the torque is tau equal to R into F sin theta. Now next which we have next formula, Hooke's law. What is the next formula? We have Hooke's law. Hooke's law formula is F equal to minus kx. So K stand for the constant, but x stand for the displacement. So let's imagine a spring. If you pull it means extend, or push it means compress. When you will pull the any spring, then that spring length will increase, means the spring will extend. When we will push, then the spring it will compress. So it fights back. When we will press any spring, then what happened? After the releasing the force from the spring, then the spring will push our hand back. Yes or not? Fight it back. So F is how hard it fight back, and X means X stand for what? Displacement, children. Here X stand for what? Displacement. So, and K stand for the constant, is simply how shift the spring is. The minus sign just means the spring pull backs opposite to the way you pull. So why we are applying the minus sign here in the Hooke's law, F equal to minus kx, because when you will apply the force over the spring, then when you will release the force from the spring, then the displacement will come into the negative one. So that's why the minus sign is here. F equal to Hooke's law formula is F equal to minus kx. Now next we are going to discuss about the Newton's second law. Newton has given three laws. What is the second law? What is the first law? Second law is, what is the first law? Newton said. Do you know, children? What is the first law? First Newton law. The Newton first law is, when a body is in a rest, then it will remain at a rest until and unless we will not apply the external force over the body. That is first law of Newton, and this law also known as the law of inertia. Law of inertia. But second law, what is the second law? The rate of change of momentum. So P equal to M into V. When we will derive, then we will get the Newton's second law formula, F equal to M into A, because the rate of change in momentum is the final momentum to initial momentum. So you will take the common M from here. Then we have V minus U upon T. So we are writing acceleration as a V minus U upon T. Yes or not, children? So that's why we will write here F equal to M into A. This is the most famous rules in physics. It says that you want to speed something up, accelerate it, you need to push it force. The heavier the object mass, the harder you have to push to get it moving. So force equals mass times acceleration. So here F equal to mass into acceleration. The Newton's second law is the product of mass and acceleration, where force is F stands for the net force which is applied over the body, and M stands for the mass, and A stands for the acceleration. What is the SI unit of the Newton's second law? F equal to M into A. So Newton per meter, Newton meter per second square, Newton meter per second square. Now next we have, next formula we have kinetic energy. Kinetic energy equal to, what we will write? Half mv square. What we will write? Kinetic energy equal to half mv square. Kinetic energy equal to half mv square, where any moving object has an energy. A fast car has a more energy than a slow one. A heavy truck has a more energy than a small bike at the same speed. So V is a square, V stands for the velocity. That means speed matters a lot, doubling your speed. So that's why here it is written in the kinetic energy formula, half into mv square. So here Ke stands for the kinetic energy in a joule, and M stands for the mass, and V stands for the velocity. So what is the SI unit of kinetic energy? The joule. And mass and SI unit we know that kg, and velocity SI unit is a meter per second square. Now next formula which we have, gravitational potential energy. What? Gravitational potential energy. So gravitational potential energy, or we can say potential energy, P equal to M into G into H. M into G into H, where M stands for the what? mass, and G stand for the gravity. G stand for the gravity and H stand for the height. H stand for the height. What is the potential SI unit? Joule. And what is the mass SI unit? You know the children. What is the mass SI unit? Kg. And what is the gravity? So gravity SI unit is a meter per second square. G SI unit is a meter per second square because it is a acceleration due to gravity. So the SI unit of G is meter per second square, and then the G value, small g value is 9.8 meter per second square, and H is a height, and height we measure in a meter. Next we have momentum. Next formula we have momentum. Momentum equal to what? What is the formula of momentum? P equal to mv. P equal to mv. This is the momentum formula. So momentum is like a train has a huge momentum because it is heavy mass. A bullet has a huge momentum because it is a fast velocity, harder to stop things with more momentum. So momentum formula P equal to m into v, where P stands for the momentum and m stands for the mass and v stands for the velocity. V stands for the velocity. Yes or not, children? So today in this live session we had discussed about the what we have discussed about children's here. We have discussed about the mechanics. We have discussed about the mechanics. First we have discussed about the friction. What is the friction formula? F equal to mu n. And what is the pressure formula? P equal to F upon A. What is the friction formula? F equal to mu into A. And what is the pressure formula? P equal to F upon A. And density formula we had learned, rho equal to m upon v. And torque we had tau equal to r into F into sine theta, where theta for the angle and F is the normal force. Yes or not? Hooke's law. Hooke's law, F equal to minus K into X. K is a constant. It is nothing but it is a constant here. And X is a displacement. Newton's second law, F equal to m into A. And kinetic energy, K equal to half mv square. Gravitational potential energy, P equal to mgh. And momentum, P equal to mv square. So that's all for today in this. So now we will give a question, and now we will discuss the question answer. So for you I am making, now we are going to discuss in a Q's. So first question here, children, for you. In universal gravitation, F equal to G into m1 m2 upon r square. What does m2 represent? So here first option, field strength meter per second square, position uncertainty, mass 2 kg, or temperature in Kelvin. Write in chat box, please. Write in chat box, everybody. So now the answer is mass 2 kg. Now next question, which equation represents velocity displacement equation? So first option is given, frac IC equation equal to 1 upon C1 plus 1 upon C2, and epsilon equal to minus n change psi delta psi upon delta t, or V square equal to U square plus 2AS. Which one is the right answer here, children? Write in the chat box. Yes, second one is the right answer. V square equal to U square plus 2AS. Now next question for you. In volume flow rate Q equal to AB. What does A stand represent? A represents. So A represents area in meter square. Which equation represents Coulomb's law? Coulomb's law. T equal to root 2 pi root m upon k root under m upon k or tau. So you know that which one is right answer? So F equal to k. K is a constant here. Yes or not? Coulomb's law. F is a force and k is the constant here. Q1 is the charge 1. Charge 1 for the body. Charge first charge and Q2 is second charge and R is the distance between both charges. R is the distance between R square is the distance between them between charge 1 Q1 to Q2. Now next question, which equation represents Ohm's law? This one. So V equal to IR. In parallel resistance, frac IR, frac 1R equal to 1 upon R1 plus 1 upon R2. What does R1 represents? Resistor 1. Now, Coulomb's law, F equal to K, Q1 into Q2 upon R square. So, what does K represents? So, K represents as a Coulomb constant. This is what is the Coulomb's formula? F equal to K into Q1 into Q2 upon R square. Now next question which we have, which equation represents Ampere's law? Ampere's law. So I equal to, Ampere's law, B equal to mu naught I upon 2 pi R. Which quantity or principle does this represent? B equal to del MC square. Now, which quantity or principle does this represent? This I didn't taught, no? This I taught or not? No. Young's module. So that's all for today in this. So we have discussed today about today in this live session about the mechanics. Last live session we had discussed about the kinematics, and today we had discussed about the mechanics. In the mechanics we had learned about the torque, Hooke's law, Newton's second law, kinetic energy, gravitational potential energy, momentum. That's it. Next we will discuss about in the mechanics same topic. Mechanics work we will discuss, power we will discuss, centripetal impulse, weight and spring potential, and then centripetal forces, centripetal acceleration we will discuss. Now let's do the cues in the kinematic. Now first question for you, in velocity time graph equation V equal to U plus AT, what does U represent? U represent for gravitational constant or focal length or gravitational force or initial velocity. So U stands for initial velocity. Which equation represents velocity time graph? Velocity time equation. V equal to U plus AT. Now, in velocity displacement equation, V square equal to U square plus 2AS. What does U represents? U represents initial velocity here. Which equation represents velocity displacement equation? Velocity displacement equation. So, P equal to rho into G into H. It is the pressure in liquid. So, we will not use this one. So F equal to m into A, that is the Newton's second law. We know that. So this V square equal to U square plus 2AS is the displacement velocity displacement equation. Now next question which we have, question number 5th. Which equation represents the displacement time equation? So S equal to UT plus half AT square, where U stands for initial velocity, T stands for time, and A stands for acceleration, T stands for time. Now, which quantities or principle does this represent? B square equal to U square plus 2AS, velocity displacement equation. V equal to U plus AT stand for velocity time equations. Which quantities or principle does this represent? Say children's. Okay, displacement time equation. In displacement time equation, S equal to UT plus half AT square, what does U represents? U represents as a initial velocity. So that's all for today in the live session. So tomorrow we will go again. So tomorrow you must have to join my live classes. In the live session, I am discussing about the formulas, and I am providing the cues related to which formula we have discussed. Through that formula, I am arranging the cues, and in the cues we are learning about the questions, many GK questions also learning through the cues, and these cues is very helpful for us, for you. So keep joining, keep learning, keep watching. Please share my channel, subscribe my channel. My channel name is Arju Education Hub. So I need your help, I need your support. Please support me and please keep watching. Thank you. That's all for today. Bye bye. Good night, everybody. Good night. Now tomorrow we will join. You have to join at 7:45 p.m. Tomorrow live session time is 7:45 p.m. So everybody, good night for today. Bye bye.